Let's do more problems. In this one, we have this cart, which is moving with the acceleration of a to the right. And we have this bar inside it with two rollers at two ends of it. So if I move this with a high acceleration, this bar is gonna roll up, something like this. If you slow it down, probably it's gonna come down, right? In one specific acceleration, it's gonna stand in this specific direction and make 30-degree angle with the horizontal direction. And the question is, with what acceleration I need to move this cart to have this bar to stay in this condition and doesn't move inside that box. So like the previous problem, the first thing we need to do is to write the free body diagram. So here we have two rollers, and because we have rollers, it is possible to have force in the vertical direction here. For this one, we are gonna have just in the horizontal direction because they are rollers. We don't have any friction, so there is no force in the horizontal direction here and nothing in the vertical direction here. And of course, we have mg at the middle as well. So A and B, they are unknown, and also acceleration is unknown as well. A, B, and acceleration. We are supposed to find the acceleration. So again, the best system of coordinate that I can use here is going to be the xy coordinate, because we have just pure translational movement in the x direction. So I'm going to use xy coordinate, Cartesian coordinate. Sum of the forces in the x direction is going to be equal to mass times acceleration of the centroid in the x direction. Again, because everything is moving just in the x direction, all the points on this bar, they're going to have the same acceleration, just a, right? So acceleration of the centroid is going to be a as well. In the x direction, the only force that we have on this bar is a. So a is going to be equal to mass times acceleration. And sum of the forces in the y direction is going to be mass times acceleration of the centroid in the y direction. But there is no acceleration. There is no movement in the y direction. Don't get confused with the gravitational acceleration. That's not the acceleration we are talking about here. If you want to have acceleration in the y direction, our part should move in the y direction, but it is not moving here. So acceleration of the centroid in the y direction is equal to 0. So may is going to be equal to 0. In the y direction, we have b, and also we have negative mg is equal to 0. And finally, sum of the moments about the centroid is going to be ig times alpha. But we don't have rotation in this bar, so alpha of it is going to be equal to 0. It is not rotating. So sum of the moments about g is going to be equal to 0. Moment of b is going to be, let's say the length of the bar is L. From here to here is L. Then this length is going to be half of L. The moment of b about centroid is going to be b times this perpendicular distance, right? From here to here. We need to multiply b to the perpendicular distance to find the moment of it about g. So it's going to be b times half a L times cosine of 30. So, and also it's going to be in the positive direction, in counterclockwise direction. So I'm going to have b times L over 2 times cosine of 30. This is the moment of b about g. And in the same way for a, we need to multiply a to the perpendicular distance from the centroid. So and this distance is going to be half of L times sine of 30. And also the direction of the moment is going to be clockwise, so it is negative. So negative a times L over 2 times sine of 30 is equal to 0. L over 2 is going to cancel out. from both sides of this equation. We are gonna have three equations, three unknowns again. And you can solve it any way you want. For example, B is gonna be equal to mg. Just put it here. You're gonna find A in terms of mg. Then if you put it here, you're gonna find acceleration. I'll let you do the math. But if you do it correctly, acceleration is gonna be equal to g times the square root of 3. And another example, problem 7, chapter 6. Here we have this card, and we have this disc or cylinder inside it. It is in contact with the card at this point, and also this point. The mass of the card is m, the mass of the cylinder is small m. We know the geometry. And the question is, with what force P I should push all of the system to the right in order that the cylinder start to roll up. What is the minimum required P? So of course, if I push it really with a lot of force to the right, the cylinder is gonna roll up and go away, right? If I push it with smaller force, this cylinder is gonna sit there and it's gonna be in contact with all of these 3 points. But in one specific P, which is minimum P, this roller is gonna start to roll up. It means it's gonna lose the contact here, and also it's gonna lose this contact here, but it's not gonna roll up. It is about to roll up. That's the meaning of the minimum P that is required for this that is required to apply to this system, so the cylinder is gonna start to roll up. I would say think about this problem for at least 10 minutes before seeing the rest of the video. Okay, if I want to draw the free body diagram of the cylinder, I'm gonna have mg, and also at this point, which is cylinder is going to be in contact at this point, it is going to be possible to have two forces. It's going to act like a pin. Let's call this point A. So I'm going to have A in the x direction and also A in the y direction. But there is no P here. We are trying to find P, right? If I want to draw the free body diagram of the whole system, I'm going to have P here, and also I'm going to have normal force, combination of all of these three forces. I'm going to put them as one, just one normal force. And also I'm going to have mg for both of the cart and the cylinder together. So the centroid of everything probably is going to be somewhere here. And the weight of all of them together is going to be small m plus capital M times g. So this is going to be the free body diagram of the whole body all together. And again, I'm going to use xy coordinate. By the way, you may ask why we don't have this ax, ay in this free body diagram. Because in this free body diagram, we are considering both of these masses together, and the contact force between these two is going to be internal. They're going to be internal forces. So we don't show them in our free body diagram. Because I have ax, ay on the cylinder, I have the opposite of that on the card. So they're going to cancel out each other like any other internal forces. Now here, what is unknown? N is unknown, P is unknown, and ax, ay is unknown, and also acceleration is unknown too. Because everything is gonna move in the horizontal direction with an acceleration, right? So I need 1, 2, 3, 4, 5, 6 equations kind of, but some of them are not going to be really useful. For example, n, you can quickly say n is equal to m plus capital M times g, because there is no acceleration in the y direction. Right? So let's start with this one. Sum of the forces in this one in the x direction is equal to total mass, which is m plus capital M, times acceleration. And in the x direction, we have only force P. So P is going to be equal to m plus capital M times acceleration. And sum of the moments about the centroid of it is going to be equal to 0. So that's not going to be really useful. So I'm not going to write it down. For this one, sum of the forces in the x direction is equal to mass times acceleration. Sum of the forces in the y direction is going to be equal to 0 because there is no movement in the y direction. And sum of the moments about the centroid is going to be equal to 0 too. So let's write them down. Sum of the forces in the x direction, which is only ax, is going to be equal to mass of the cylinder, which is m, times acceleration in the x direction, which is a. Sum of the forces in the y direction is equal to 0 because there is no acceleration in the y direction. And from there, ay minus mg is going to be equal to 0, or ay is going to be equal to m times g. Some of the moments about centroid g is going to be equal to I times acceleration, rotational acceleration, which is 0 because it is not rotating, right? So sum of the moments about g is going to be equal to 0. And before doing that, this height is equal to r divided by 2, and this height is going to be equal to r divided by 2. So this is r divided by 2, this is r divided by 2. So this angle, sine of this angle is going to be r divided by 2 divided by r. So this is going to be 30 degree, right? So this angle is 30 degree, or we can say this angle is equal to 30 degree as well. Moment of mg about g is equal to 0 because it is passing through g. Moment of ax is going to be ax times perpendicular distance, which is r over 2, or r times sine of 30, which is r over 2. So, and also the moment is going to be in counterclockwise direction, so it is positive. Ax times r divided by 2. A moment of ay is going to be counterclockwise. It's going to be clockwise, so it is negative. And the value of it is going to be ay times this distance, which is r times cosine of 30. So I'm going to have negative ay times r times cosine of 30 is going to be equal to 0. Or I can simplify it, r is going to cancel out and say ax is going to be equal to root square of 3 times ay. And I know what is ax. Ax is in terms of acceleration. And also I know what is ay in terms of mg. So you can actually put them here to find the acceleration in terms of mg. So let's do that. Ax is equal to ma, and ay is equal to mg. So from here, acceleration is going to be equal to the square root of 3 times g. Now, I can use the other equation to find p, right? So let's call this one 1 and this one 2. From 1 and 2, p is going to be equal to m plus capital M times the square root of 3 times g. So that's going to be the minimum required force that we need to apply to this cart in order to that cylinder to start to roll up. It is not really rolling up, it is starting to roll up.